Um, I'm very excited to introduce our next speaker, Zuby Onwuta. Zuby is a Harvard MIT trained innovator. He's a President Obama Service Award recipient, a US Army veteran. He's a patented inventor of brain control for blind tech. He's founder CEO of Think and Zoom, a 4-time TEDx speaker. He is legally blind and an advocate of the United Nations and the US Congress. His aim is to inspire and empower all people to dream big and believe in themselves so they can pursue their goals and achieve their dreams. His educational background includes a degree in engineering from the University of Illinois, as well as innovation certificates from MIT, Harvard Business School, as well as Harvard Medical School. It's with great delight that I would like to welcome Zuby Onwuta to the stage.
Thanks. Good morning, everybody, and thanks so much, NMA, for having me here. Thanks to Dr. Stephen Odaibo for making this possible. I came in late last night. Sorry I missed having dinner with some of you. So 11-hour flight, 3 hours of sleep, put it together. So in case I doze off in the middle of the presentation, please be kind. I ask you to do me a favor, just look and think, and I will zoom in to continue. All right, can anybody see that very well? No? No? Why, what's the problem? It's blurry? Wait, are you sure? That's how I see you. So I can argue right now that you are experiencing a learning disability because you're struggling to see. How about now? It's better? All right. So I'm Zuby Onwuta, like he introduced me, I am legally blind. My journey started when I was a teenager and I left my home country of Nigeria to come to America. And I was so excited, I won the visa lottery. I picked up my dream in my front pocket to become a medical doctor, a duffel bag, and $200 to go to medical school, right? So when I arrived, I quickly realized I was going to need a whole lot more money. And in order to, fulfill my dream, I decided to serve the country that was giving me this great opportunity. So I started pre-med, and I joined the US Army. And quite frankly, life was great. But then barely 2 years into both, things started going wrong. Strike one was I became legally blind. Within 2 years, I went from 20/40 to 2200. I was diagnosed with Stargardt's macular degeneration. Of course, that earned me a medical discharge, and my pre-med went along the way. Battled with a lot of depression, but when I came out of it, I said, okay, let me try engineering. Now, while going into engineering, I kind of learned about Stargardt's. It takes you to 2200, you become legally blind, but then it stabilizes. You cope with blind assistive technologies, magnifiers, sometimes text-to-speech or readers, but you should be fine, it's stable. Now, my symptoms never match my diagnosis. So I went into engineering and I struggled all through because my vision kept fluctuating as it continuously declined. I did manage to graduate, started working full-time, and then found myself at the School for the Blind. Came out of there, continued. But throughout all this period, I knew something was wrong. I knew that the things I was hearing wasn't quite complete. So I threw myself into research, and I saw about 300 of your colleagues, 300 eye care professionals later, a decade and a half and 2 weeks at Johns Hopkins with some genetic testing, we got the full picture. So I actually have 3 genetic eye defects. I have 2 defects that contribute to Stargardt's and 1 that contributes to Conrad dystrophy. So what is it like to deal with that? Well, imagine if you have 1 computer virus. Now, it's going to be very annoying because sometimes your system locks up and you don't know what's going on. Now add 2 more to it. Now it becomes extremely very unpredictable. So that's what I mean. And I seriously mean, if I doze off, please look and think so I can zoom in to continue. So throughout all this journey, I started researching on how to, make the situation better for myself and others. And the core problem is really the blind assistive technology solutions that are out there. They're simply inadequate, and these are some of them. magnifiers, screen readers, white cane, right? And I dedicated myself to try to come up with a way to, improve the situation. And I am not alone in this journey. Globally, there are upwards of 300 million people who are visually impaired or disabled or legally blind. About 15% of them are actually totally blind. And the illiteracy rate around the world is at 90%, 9 out of 10 people. So that is huge. And then in terms of unemployment, here in America, there are about 22 million people like myself who deal with a 70% unemployment rate. And last time I checked, we're in an economic boom, right, when we have very low unemployment rates. But still, for this demographic, we're still suffering. And the numbers don't get better with other countries. The UK is at 75%, South Africa is all the way at 98%. It doesn't get any different when you compare other countries. So while everybody else is similarly doing well, we are still, at the back, still struggling because of inadequate blind assistive technology. And when it even comes to the older generations, for people that are deal with the baby boomers who are turning 65, 20% of them are affected by macular degeneration, so they all become legally blind. And people who are over 50, a lot of them end up very prematurely in nursing homes. Because if you look at it, they are 50, 55, they've been working for decades, and all of a sudden something starts affecting their eyes, and then somebody's telling them to start using these things called screen readers, magnifiers. The person just throws up their hands. I don't want to deal with this. And so they lose their economic viability. Now, what are some of the solutions that are out there? Not picking up Microsoft, but let's focus on this particular one called RETINA-AI. RETINA-AI is great, right? It's a mobile application. You download it on your smartphone. It has great computer vision. It can read business cards, so short text. It can read long-form text in pages. It can tell you colors. Even it can tell you some currency, right? But it has some drawbacks, and these drawbacks are similar to all the other assistive techs that you're going to come across. So first, you kind of have to manually operate it, right? I mean, I think I see everybody sitting down and looking at me. I don't think there's anybody holding both eyeballs with one hand and using the other to crank it and fine-tune it, right? But that's the experience that most blind assistive technology offers, that manual operation, that hand-holding. And so what it does is it limits one's functionality and impedes the ability of that person to produce and to be efficient and to compete with everybody else. So how can we improve upon this? So that's what I said about. I said about trying to figure out a way to first remove the hand-holding, right? No hands, look, no hands, right? Make it hands-free, first of all. And then the second thing is now the control or the commands. First, I wanted to automate the commands. I don't want to have to learn any extra commands just to use my assistive tech. I don't know if you guys are familiar with things like screen readers. In order to just open up a new browser while using the screen reader, you literally need 2 hands and 2 fingers on each hand to control all the shortkeys. It's very inefficient. So I wanted to automate the commands. But then the third thing is, okay, no hands, automated commands, but how do you control it? How do you send the controls? Well, what about brain control? Can we use our mind? Actually, today we can. We can leverage electroencephalograms, right, EEG. Over the last 7 to 10 years, certain companies have started making mobile versions, and I have one here, very similar to the one you see in the picture, and there's a sensor that touches the forehead. So by leveraging EEG, we can tap into our brainwaves. And these brainwaves are a result of the massive neurons that we have in our brains, which when they communicate, give rise to all our thoughts, emotions, and behavior. So we can leverage these brainwaves and use them to control digital devices.
Are you visually impaired or just need to see things up close? Introducing Think and Zoom. Think and Zoom detects your focus through the MindWave EEG headset and tells the camera on Google Glass to zoom in. Blink to snap a picture and see clear detail even at a distance. Ever wished for a way to zoom without cords, handheld remote controls, or buttons? It's as simple as that. Just look think, and zoom. Introducing Think and Zoom.
What that gentleman is wearing is this brainwave reader, and he's also wearing Google Glass, right? And we've been able to pair both of them together where we can send his brainwaves to the Google Glass. So essentially anything that has software, that has a display and an operating system, we can harness the brainwaves and use it to control that thing. In this situation is Google Glass. And the result is that when he looks at something and thinks, he can literally zoom in to see it better. So we harness the ability of humans to focus or concentrate. The thought behind that is that if I ask you to look at something that is really far away, like a football field away, you'll kind of squint or concentrate or focus more. And by doing that, you eke out focus signals. So we tap into those focus signals to be able to control digital devices. And being that the Google Glass was kind of very small for me to see, I simply ported it to an iPhone. And this is a demonstration that was shot right outside of TMCX, Texas Medical Center. Hi, folks, I'm in a restaurant. And I'm struggling to see the menu. Take a look at that. See how blurry it is? This is what it looks like for those who are visually impaired. Is there an easy way for me to just see better? Is there an easy way for me to see the menu so I can just simply order something to eat? Can I use my mind to make that screen clearer? Let's give it a shot. All right, let's see what's happening now. Aha, it's getting clearer. And I see chicken. So what do we plan for the future? What is our hope? What is our vision for the future? Well, for the future, we want to fuse it all together, right? Rather than having these discrete pieces of hardware. We want to put it all together in something like this, and thanks to the people at DACRI, who I met last year for allowing this photo. But with this kind of hardware, what we want to do is, A, have that EEG sensor touching your forehead, right? And this already has a display, and it's going to have an operating system. And when we harness the brain waves, we will influence magnification and text-to-speech. And AI, or machine learning, will be the one that's going to be able to manage all of that, right? We're going to run ML against all that brainwave and just simply treat it as data and just try to sense whenever somebody's struggling to see and then provide them with some relief. And these are some of the places we've been very fortunate to speak at, Johns Hopkins, USC Medicine, and a host of other places. And these are some of the validations that we've had. We've been invited to South by Southwest. And one of the crazy ideas we have actually to deploy the solution to the market is by tapping secondary market in terms of video gaming, because video gaming currently is at 140 billion and growing at almost 14% per year. So we actually designed a game which won an award at Apple WWDC, and by simply thinking, you can lift a bird out of a cage. And we've been featured several times on TEDx, and we also earned a patent last year. So wrapping up, our vision for the future is to modernize assistive technology. There are millions and millions of people who are suffering around the world simply because the assistive technology they rely on to cope with everyday tasks is inadequate, and so they lack the ability to be self-reliant and economically viable. So we want to refresh assistive technology, simply modernize it and make it ready for the 21st century, and we'll simply want to leverage brainwaves to do that so that everyone can have the ability to look, think, and zoom into a better, brighter future. Thank you.
Quick question.
Sure.
What types of diagnoses would be applicable for this type of technology, macular degeneration versus, I don't know, retinal hemorrhage, I don't know, just what? I mean, are you saying it could be possibly applied to any any visual impairment?
Yes, rather than looking at specific diagnosis, look at it from the other angle, meaning anyone who relies on assistive technology, whether it be a magnifier or a screen reader, now has a better way to use that assistive technology. So these are people already using assistive technology. So rather than looking at the specific diagnosis, just look at the people who have already been diagnosed as being low vision or visually impaired or legally blind, who are already using assistive technology. We simply make it better and a better user experience. Thanks.
Again, excellent talk. Way to
Thanks.
turn a problem for one into a solution for all. This morning, I actually read a brief about a contact lens that will zoom in on things when you blink.
Yes.
So I was wondering, of course, I'm jet lagged, so I'm reading at 3 in the morning. But have you thought about making your technology also on a contact lens platform?
Yes, I actually recently saw that article, and if I remember correctly, the article states that the contact lens is designed where when the wearer blinks twice, then it zooms. Okay, now how many of you have blinked twice just to see me better? Nobody, right? So that is the critical missing piece where folks who are well-intended, right, that they have a good intention to make these technologies, however, they themselves don't have the problem. In my second TED Talk, I talked about phenomenal disabled user innovators, right? Chieko Asakawa and many other people. So I think that when companies want to develop these technologies, they need to partner with disabled user innovators who experience these problems day in, day out, right? To be able to bring about certain innovations that can greatly improve the user experience. Thank you.
Thank you for the excellent talk. I was just wondering, what are you using on your glasses to also look at us and look at the computer screen?
So these are just your regular correction glasses. In terms of the computer screen, I can't see it very well, so he gave me a clicker. So I'm looking at it, but I'm not seeing it very well. If you're an ophthalmologist, you've seen, patients with, Stargardt's, macular degeneration, retinitis pigmentosa. You know that you give them correction glasses, but you also know that despite the correction glasses, they don't see very well. With this correction glasses, if I were to do the eye chart, I think last time I checked, it was well beyond 2200 because once you hit 2200, they don't really measure anymore, right? So I hit 2200 with my glasses back in 98. So, so if you really were to measure, maybe it's 2800 or something, So don't really see very well with them.
Any other questions?
All right. Thank you very much.
All right. Very exciting session. I'm so thrilled and I'm having a lot of fun.